For this example, we're going to be looking at the topic solving radical equations. So the problem we have here is the square root of 2k plus 7 is equal to the square root of k plus 2. Notice in this problem we have two radicals, okay? We have that square root of 2k plus 7, and we also have that square root of k. So our first step here is to get one of the radicals by itself. And notice that this radical right here is already by itself. So we have that step done for us. Then we want to end up canceling out that radical, and we can do that by squaring both sides. So that's what we're going to do first. Okay. So that means on the first radical, when we square it, that radical canceled. So we're left with 2k plus 7. However, on the right side, we can't just square each individual term here. That square root of k plus 2 squared is telling us that we're going to have to write that parenthesis 2 times. Square root of k plus 2 times the square root of k plus 2. When you see those parentheses together like that, your first thought should be to use the FOIL method. So that's what we're going to do. Okay. Rewriting my left side. And now I have square root of k times the square root of k, which is k. The square root of k plus 2, or times a positive 2, is 2 square roots of k. 2 times the square root of k is again 2 square roots of k. And 2 times 2 is 4. Okay. So combining like terms, we have k plus 4 square roots of k plus 4. Okay. So what we did is we got rid of that first radical. Now we're going to have to isolate the other radical to get rid of it. So we need to isolate that square root of k, which means I'm going to subtract 4 to the other side and subtract k. When I do that, I'm left with k plus 3 is equal to 4 square roots of k. Okay. I want that square root of k by itself, so I'm going to divide both sides by 4. When I do that, I am left with k plus 3 over 4, I'm going to keep it as that large fraction, is equal to the square root of k. Now that I have that radical isolated, I am going to square both sides just like I did in the beginning. When I do that, the square root of k and the square cancels. And that square is going to go to the numerator and the denominator separately. So I have k plus 3 squared over 4 squared, which is 16, is equal to k. Okay. Now, what I'm going to do is I'm going to go ahead and move that 16 back over. So I'm going to multiply both sides by 16. And I have k plus 3 2 times, because that's what that square says, is equal to 16k. Again, if I see those two parentheses next to each other, that tells me I'm going to have to FOIL. So I have k times k, which is k squared, k times 3, which is 3k, 3 times k, which is 3k, and 3 times 3, which is 9, is equal to 16k. Notice here that I have k squared in my problem now. This should tell you that we need to get everything moved over to the left side so we can have our equation equal to 0. Okay, so I'm going to subtract that 16k over, and I'm combining all my like terms. So I have k squared, 3k plus 3k is 6k, 6k minus 16k is negative 10k, plus 9 is equal to 0. This now looks like a quadratic equation. Remember, in order to solve quadratic equations, we're going to have to see if we could factor this. So we are going to be using the AC method to factor. So we have A times C, which is 1 times 9, which is 9. And then we have our B value, which is negative 10. So we need two numbers that multiply to 9 but add to negative 10. And those numbers would be negative 1 times negative 9. Because when we multiply those, we get a positive 9, but when we add them, we get a negative 10. So these are the numbers we're using. Remember, once we have those numbers, we are going to expand our B value so we can do factor by grouping. So I have k squared minus k minus 9k plus 9 equals 0. Factor by grouping tells me I group the first pair and then I group the second pair. And then I'm taking a GCF out of each. So out of the first parentheses, I can take out a k, and I'm left with k minus 1. And on the second one, remember, I want my parentheses to match. I'm going to take out a negative 9, so I'm left with k minus 1. Okay. So that means I have my two factors of k minus 1 and k minus 9 is equal to 0. Once I have my two factors, I'm going to set each one separately equal to 0. So k minus 1 equals 0, k minus 9 equals 0. Then I solve for k individually. So in this first one, I add 1 over, and I get k is equal to 1. And then the other one, I add 9 over, and I get k is equal to 9. Okay, so now I solved for k. Okay. However, since I have these radicals in here, it's always safe to check my work. And so I'm going to check my work by plugging in 1 for k, and then plugging in 9 for k. And if I get a true statement for both, then they are indeed my correct answers. Okay, so let's go ahead and do the check. I'm going to go ahead and trying to move all this over just so I have a little bit more space. But I think I need to, oops. Let's try that again. Okay, there we go. So we're doing our check. So remember, our numbers are 1 and 9. Okay, so this is our check. We're going to first check when k is equal to 1. So I have the square root of 2 times 1 plus 7 is equal to the square root of 1 plus 2. So all I did was plug in 1 in for my k value. So simplifying this, I have the square root of 2 plus 7 is equal to 1 plus 2. Square root of 9 is equal to 3. And 3 is equal to 3. This is a true statement, so that means k equals 1 is a solution. Now I'm going to check when k is 9. That was the other one we got. So check k is equal to 9. So I have the square root of 2 times 9 plus 7 is equal to the square root of 9 plus 2. So simplifying this, 2 times 9 is 18, so 18 plus 7 is equal to the square root of 9, which is 3 plus 2. Okay, 18 plus 7 is 25, so we have the square root of 25 is equal to 5. 5 is equal to 5, so this is a true statement, which means that k equals 9 is a solution. So again, the answers to this problem was 1 and 9.